Hi, today I'm going to show you how to get root access to Shenron 1, which is the first of 3 machines in the Shenron series. As always, I will do my best to explain why I do each step so you can apply this knowledge to other challenge machines. If you have a particular machine or series that you'd like me to tackle, let me know in the comments. Let's get started. The first step of any challenge is to identify the target machine. To do this, we first use the ifconfig command to find our host machine's IP address. In my case, that is 10.0.2.25, so I can use the nmap tool to scan for everything on the 10.0.2.something network with the command nmap 10.0.2.0/24. We can see our target machine there with an IP of 10.0.2.34, so let's use nmap again, but this time we're only going to scan our target machine, and we're going to search for some more detailed information, including service and version detection. To do that, we can use the command nmap -A 10.0.2.34. Our target machine only has 2 ports open, port 22, which is an SSH port, and port 80, which is an HTTP port. Given that we don't have any credentials at this stage, the SSH port isn't going to do us much good, so instead we're going to focus on port 80. Open up your web browser and navigate to the hosted web server using the target IP address. Unfortunately, this too doesn't give us much to go on, as it's just the default page for Apache. Our next step then is to search for any hidden directories or pages that contain useful information. If you want an explanation of how directory enumeration works, I cover it in more detail in my Lupin video, but for today, we are just going to use any directory enumeration tool. In my case, that's going to be GoBuster. Let's run the command gobuster dir -u http://10.0.2.34 -w/user/share/wordlists/derb/common.txt. In other words, run GoBuster in directory enumeration mode against the target URL and using the common.txt word list. We can see that it has uncovered 2 directories, Joomla and test. One thing I will say that I don't like about GoBuster is that it doesn't do recursive searches, so let's run it again on both of our newly discovered directories. We can do this with the same command as before, this time replacing the URL with the URLs for the desired directories. We can see that the Joomla directory contains several subdirectories, including one called administrator, something we always want to keep an eye out on for these challenges. Let's check out the main page first. It takes us to a login page. Now, let's try the administrator page. It takes us to a second login page. Okay, let's head back to our GoBuster results. We can see that the test directory contains a page called password, so let's check it out. It takes us to a blank page with some text and the hint that we are very near. Sure enough, if we check the page source, we see some admin credentials. If you try these on the main Joomla page, they don't work. So instead, let's go to the admin page and enter our newly discovered credentials. We can see that we are now logged into the Joomla control panel. Our next step is to find a way of creating a connection into the target machine. Because we have admin access to the Joomla control panel, we are able to modify objects within it. What we are looking for is anything that we can insert our own code into. That way, we can take an object, insert the code for a reverse shell, and then when that object is run, it will execute our code along with it. The object we are going to modify is a template written in PHP. In the configuration menu, select Templates, then on the left-hand menu, select Templates again, then protostar, details and files, and open up index.php. We're going to select and delete everything and replace it with a PHP reverse shell. Kali comes with a bunch of shells that you can find in user/share/web shells, or you can find them online. I'm going to use Kali's default PHP reverse shell, making sure that I have changed the port and IP to my host machine IP and my desired port, in my case 1234. Copy everything from your reverse shell and paste it into the index.php file and save. Now that we have our code ready to start a reverse shell, we can set up a listener on our host machine. We can do this with netcat using the command nc-lnvp1234. This runs netcat in listener mode, disabling DNS resolution, in verbose mode, and on port 1234. Finally, use your web browser to access our newly modified index.php by entering http://10.0.2.34/Joomla. If all has gone well, we can see on our listener that we have an established web shell. Let's upgrade to a proper bash shell with the command python3 -c open single quote import space pty semicolon pty.spawn open bracket open double quotes /bin/bash close double quotes close brackets close single quotes. In other words, use the Python 3 interpreter to import the pty module and then spawn a bash shell. Let's check out the home directory with cd/home. We see two users, Jenny and Shenron. Unfortunately, we don't have permission to access either of these directories. At this stage, I want to know what files can only be read by these users. We can use the command find /user Shenron -ls to >dev/null. In other words, find all files belonging to the user Shenron, starting in the root directory, and list them out while suppressing error messages. This turns up a file called password.txt, but we can see that only Shenron has permissions to read it. I tried the same search message with the user Jenny, but didn't find anything interesting. The next place to try is inside configuration files. Navigate back to the web directory with cd/var/www/html/joomla. List out the contents with ls and use cat to read the configuration.php file. We can see that we have a password for the user Jenny. Now, technically, this password is for a database, not as a local user, but as people use the same password for things all the time, it's worth a try. Let's switch user to Jenny with the command su Jenny, and then paste in the password. Sure enough, it works, and we are now logged in as Jenny. Now that we are logged in as an actual user, let's see what privileges Jenny has. We are looking for objects that Jenny has root permissions for that we can exploit. Let's search for them with the command sudo -l. We can see that Jenny is able to run /user/bin/cp as the user Shenron. In other words, we can copy stuff. So what we want to do is to log in as Shenron via SSH. To do this, we need to generate a public key. SSH relies on asymmetric encryption, meaning it uses two different but related keys, a private key and a public key. The public key for my host machine is typically placed into a file called authorized_keys in the SSH directory of the target user's home directory on the machine to be accessed remotely. The private key is then stored securely on the host machine. When my host machine tries to connect remotely to the target machine, the SSH client offers my public key to the target machine. The target machine uses my public key to generate a challenge, which it sends back to my SSH client. My client then uses my private key to sign that challenge and return it back to the target machine. The target machine then uses the public key it already has in its authorized_keys file to verify the signature. Once verified, access is granted. The technical details are more complicated than that, but for our purposes, it's more important to understand what's happening on a conceptual level than a technical one. All of this to say, if we want to access the target machine via SSH as the Shenron user, we are going to need a public key, and we are going to need it placed inside the authorized_keys file within the SSH directory of the Shenron home directory. Of course, you may remember that we aren't able to access the Shenron home directory, and that is where we are going to take advantage of Jenny's ability to copy files with root permissions. First things first, let's generate a key. Use the command ssh-keygen. You can leave the name of your file blank to use the default settings and enter a password of your choice. I will use password to keep things simple. If we navigate to Jenny's SSH directory using the command cd/home/jenny/.ssh and then use ls to list the contents, we can see that we have a file called id_rsa and another called id_rsa.pub. These are our keys, and as you might have guessed, the .pub one is the public key. Let's make a copy of the public key, place it in the temp folder, and rename it authorized_keys so the SSH client can recognize it. We can use the command cp id_rsa.pub /tmp/authorized_keys. Just a note here, if you're not American, make sure you spell authorized the American way with a Z, or the SSH client will get confused. Navigate to the temp folder with cd/tmp and list the contents with ls. We can see our authorized_keys file is there. Next, we need to copy it over to the SSH directory for Shenron, exploiting the fact that we can do this with root permissions. Use the command sudo -u Shenron/user/bin/cp /tmp/authorized_keys /home/shenron/.ssh/. With that done, let's log in as Shenron via SSH. Use the command ssh shenron at localhost. Enter your chosen password, in my case it's just password, and we are now logged in as Shenron. Use the cd/home/shenron to access the previously inaccessible directory. Use ls to view the contents, and cat local.txt to read the user flag. Next, remember that password file we couldn't read earlier? We should be able to read it as the Shenron user, so let's use the command cat/var/opt/password.txt. This reveals to us the password for Shenron. Once again, we want to know what this user can do with sudo permissions, so let's run the command sudo -l and copy and paste the password. It turns out that Shenron can run the /user/bin/apt binary with root permissions. Being able to run this as sudo allows for privilege escalation. We can use this long command, sudo /user/bin/apt update -o $A P T : update with a capital U, pre-invoke with a capital P and a capital I, equals /bin/sh. Put simply, we are telling the system to update the list of available packages, apt update, and using a pre-invoke hook to open a shell before that occurs. Because we are able to run this with sudo permissions, we can open up a root level shell before anything else actually occurs. All that's left is to find the root flag. Use the command cd/root to move to the root home directory, ls to list the contents, and then cat root.txt to read the flag. So there you have it. We have completed the Shenron 1 machine. So how did we do it? We used nmap to perform a network scan and identify our target machine. We used GoBuster to perform directory enumeration. We then used code injection to create a reverse shell and give ourselves user access. Next, we performed some manual enumeration to find a user password and switch to that user. We searched for processes that could be run by that user with elevated permissions, and exploited those permissions to copy our generated SSH key into the SSH directory of a different user. This allowed us to connect via SSH as that user and access previously inaccessible files. From there, we once again searched for processes that could be run with elevated privileges, and exploited the APT binary to give ourselves a root shell. I hope you enjoyed this machine and found this walkthrough and explanation helpful. I am going to do the other machines in the Shenron series next, but if there is a particular machine you would like me to cover, let me know in the comments. Until next time, good luck with your own hacking exploits.